So I've worked with emissions inventories for about 10 years in quantifying emissions, both in the air quality and in the greenhouse gas space. I'm still learning, but I believe I have a bit of understanding of how you quantify emissions and what they are used for. In preparing my presentation, I'm going to quickly run through the concept of sustainability and how to reduce greenhouse gas emissions, and then talk about emissions inventory on a very high level. I guess one of the issues that you have when you're given a blank check that you can talk about anything is that then you don't know, you get to that point where you want to talk about everything. But then, so that was the issue I had. I didn't know how not to lose focus. But for me, when we talk about reducing emissions, I always want to go back to the concept of sustainability, because at the end, what we are trying to achieve is sustainability. If you look at the chart I have up, I've tried to, well, the author of this slide has tried to chart out for us what they would think would fit into a sustainability concept. So the concept of sustainability in today's world would include some of the following components, which will include energy efficiency, complementary system, reliable infrastructure, a concept called circular economy, durable systems, as well as profitability, because every organization, every nation, or every community needs to achieve some level of profitability. So in this slide, I've tried to because the focus is on Africa, I wanted to bring up some facts regarding our current CO2 emissions. So currently in Africa, we currently emit about 2 to 3% of the world the total world emissions, which is about approximately 1.5 billion tons of CO2 equivalent per annum. If you look at that chart, if you look at the diagram to your right, you would see there, just to zoom it out, what this chart has tried to quantify what the various emissions from various nations looks like. If you look at China there, I'm not sure if you can see my mouse, China compared to the United States to your right.
Yes.
And then you have, so Africa is in the, I would say, populist zone there. You have South Africa there, you have Egypt, you have Nigeria, you have Algeria there, you have Libya. And then all the smaller, tiny circles there, they are different, your various countries in Africa. And you can see how our emissions relate to the other nations of the world. This is just to and having said that, you would want to ask, why then are we bothering ourselves to reduce emissions in Africa if we are not, if we only generate, say, 3% of the world total emissions? But the problem here is that Africa is said to be the most vulnerable continent to the impacts of climate change. So we really need to do something. We can't wait for the developed world to take the lead, or to just do everything. We have to put in our part in reducing greenhouse gas emissions. I'll move forward now. So in terms of a holistic approach, I'm looking at a holistic approach to reducing emissions. So in today's world, we look at a concept called the circular economy approach, where when you're designing a system, so in the design or concept phase of whatever project, whatever, if you want to design a new development, a project, an eco-city, for instance, you look at the concept of circular economy, because you don't want to wait until you get to operational levels before you start reducing emissions. So at the concept level, you design the project or the development to be able to depart from the linear economy model that we currently have, which takes waste, which takes resources, produces products. The products get used and then it goes to the waste. It gets to be disposed of. So now the circular economy tries to reuse and recycle at every point in the value chain. So you're basically redesigning how cities, how development, how projects are operationalized. Also, to reduce emissions, greenhouse gas emissions specifically, industries now tend to look at processes, systems and processes optimization. So in terms of energy efficiency and lower resource consumption. Also, another very vital point to reducing greenhouse gas emissions is energy transition. Dr. Sam has already mentioned some of this. So it might seem like a repetition. Energy transition to lower carbon, alternative materials in terms of using biofuels and the likes, and then transition to reuse and recycling of waste. For instance, you have your waste to energy technology that is starting to become the norm now. Also, you can retrofit emissions reduction technology to your plant, for instance. That's another reduction reduction technique. Lastly, here I have carbon capture and storage. It's not a reduction per se, but it's a way of it's a sink. So you have a process where the carbon that is released is being removed from the environment. So I've just put it in here. It's not really an emissions reduction technique per se. Moving on to the next slide. I'm going to be quick now. So looking at emissions inventory, I say here that what you do not measure or what you do not quantify, you cannot control. So emission inventory is very important because you need to know what you are releasing before you can attempt to control or quantify or to reduce it. So Dr. Sam has mentioned this. In terms of how to quantify emissions, you have direct measurements, you have mass balancing, you have few analysis or generic calculations. I'm not going to go, these are quite technical method, and you have emission factors. So the use of emission factors, in my opinion, is well, it's quite extensive, and it's the simplest and easiest for organizations to use in quantifying emissions. Direct measurements, while maybe accurate, is quite expensive and takes time to put together. So the next slide talks about the sources of emissions. So in any system or in any project, you're going to have different, and I guess perhaps some of the contributors in the morning section have walked us through this already. So in every system and in every project or every development, you would have different emission sources. You have your point, your area, your line sources. You have a different kind of sources. And it's important to identify all the sources in your emissions inventory and quantify the emissions as per those sources. So let's look at emission factors because, like I said earlier, it's one of the easiest way to measure your emissions. So you have, I've just given an example here because I don't know the technicality of the participants in this forum. So simply put, an emission factor gives you the ability to calculate your emissions by having a representative value. So for instance, if your facility consumes 50,000 liters of fuel per annum, you have what you call emission factors. So that emission factor has been calculated over time, and there's a lot of science that's gone into it, and it will tell you, for instance, that for every liter of fuel you burn, then I'm giving an assumption now, so I shouldn't be quoted on this. So it says, for instance, for every liter of fuel you burn, 0.01 CO2 equivalent of equivalent is released. So you're releasing 0.01 CO2 equivalent of greenhouse gases for every liter. So if you have 50,000 liter burnt per annum, then you just simply multiply that by 0.01 to get your CO2 equivalent for that year. And then if you have some sort of emissions technology place at the facility, if that is say 40%, you just take that into account when you're calculating, and you have your final emissions. So here I've just listed a couple of tools that might be useful to look at, because there are very enormous. There's a lot of, as Dr. Sam has mentioned, there's a lot of tools, there's a lot of guidelines and calculation manuals you use, and they are all they are given per industry, per source types, and the likes with the organizers, so that whoever can have. So basically, what you don't measure, you cannot control. And as Dr. Sam has said, a collaborative effort is needed when we talk about climate change and greenhouse gases. I've not gone into the rudimentary of climate change because I believe that must have been covered at some point. So thank you very much. I hope I have been able to provide some sort of knowledge or addition to the knowledge for the participants. Thank you.
Thank you very much, Dr. Ola, for your presentation. We have gained a lot during the course of your presentation. It was quite a delightful presentation. And I actually support your point on the transboundary air pollution. Speaking of Africa as a continent being the most vulnerable continent to the impact of climate change. And there has been convention on long-range transboundary air pollution, having about 51 parties in Europe, North America, and Central Africa, and Central Asia. So this has actually been something that has been looked into for some time now, so that the effect of this transboundary emission can be cushioned, and as much as possible it can be reduced until we find a way to completely eliminate it. So thank you so much for your presentation. Right now I would like to read some of the questions that we received from our participants during the course of your presentation. We had the first question from one Matthias. His question goes to Dr. Samuel. His question goes to Dr. Samuel. He's asking that where a